We're at the Play to Learn website looking at the SPS Now descriptive statistics for scale variables. Scale variables are where we have numbers you can add, subtract, multiply, divide, and calculate the average of. Here is our tutorial game. You can click the start button on it or scroll a little further down and click the link for open the game in full screen mode. This is especially desirable if you're using a mobile device. To get started, again, just click the start button. Our learning objectives. As a result of doing this activity, increased familiarity and confidence with SPSS, gaining experience with analyzing variables and creating histograms. You are evaluating a distribution to determine is it fairly normal, in which case we would write up our results with the mean and standard deviation, or would we consider it skewed or having an outlier, in which case we would write up the results by reporting the median and the interquartile range. And finally, for an awareness of APA style for descriptive reports. Heads up, SPSS is a registered trademark. Screen images are copyright by SPSS. The tutorial is not sponsored by SPSS. Likewise, Google Docs is a registered trademark of Google LLC, and screen images are copyright by Google LLC. Okay, so this is what we would envision ourselves creating at the end of this tutorial and game activity. We have here two scale variables. One of them is units this semester, and just heads up, this is fairly normally distributed, and the other is enjoyment of art, and it is heavily skewed. So whether something's fairly normally distributed or heavily skewed influences the way that we're going to write up the results. If it's fairly normal, as mentioned, we would share the mean, shown here with an italicized M, and the standard deviation, shown here with an italicized S. If it's heavily skewed or there's an outlier, then we would report the median, which is an italicized MDN, as well as the interquartile range, shown here as IQR. Okay, so this tutorial is going to involve three steps. First, analyzing the data. Second, evaluating the distribution for normality. As you can see, it's going to influence then how we write it up. And then a demonstration of writing up the results APA style. We'll do this first in tutorial mode, and then we'll take a look at it in game mode. All right, so analyzing the data, we'll look at selecting the variables and including histograms. Let's get started. So we're looking at a screenshot of SPSS, and to do the analysis of our scale variables, we're going to go to the Analyze drop-down menu. We're going to choose Descriptive Statistics and then Frequencies. Then we'll select our variables, so we'll go with enjoyment of art. And by the way, if you select any of these variables and then just press the letter E using the real SPSS, it'll take you to a variable that starts with an E. So it's an easy way to find a variable. Okay, we'll move it over, scroll down, and here's our units this semester, our second scale variable we're working with. We'll move it over. Now we're going to select our statistics. So we may need to report for our measure of what's typical, the mean, or the median, right? That depends upon whether it's fairly normally distributed, that'd be the mean, or if it's skewed or outlier, that'd be the median. In terms of how much variability there is, it'll either be the standard deviation, or we'll go with quartiles in order to calculate the interquartile range. And finally, we'll request a measure of skewness from SPSS to evaluate how normal is this distribution and to share that then with others. All right, we got our 5 statistics here. We'll continue. We're going to go to charts where we'll select having a histogram. Histogram is a graph that follows along a number line, so that works for our scale data. And we'll superimpose a normal curve over our histogram. Click continue. And having tables can be helpful if there's a limited number of values for your scale variable. So for like enjoyment of art, it could be reasonable because there's 7 different responses. But for units this semester where answers could be anywhere from 3 to like 23 or more, that starts to get too extensive for a table. So generally when I work with scale variables, I just uncheck this. But you go with what works for you. And then I'll click OK. And here's our SPS output. So we have the statistics table, and it gives us those stats that we had asked for: mean, median, standard deviation, skewness, gives us the standard error skewness, and then the percentiles. That's because we checked quartiles. So we're going to go ahead and copy this and put it into a word processing document. In this case, we're working with Google Docs. To copy it on a Windows device, it'd be Control-C. On a Mac, it'd be Command-C. Or we could right-click it and choose Copy. Or we could go to the Edit drop-down menu and choose Copy. So lots of ways to do that. Having copied it, here's our word processing document. We would paste it, either Control-V for Windows or Command-V for Mac, or right-click and choose Paste, or go to the Edit drop-down menu and choose Paste, right? So lots of ways to then paste it in. And now we'll go back to our to SPSS, and we'll grab our two graphs. So enjoyment of art histogram, we'll go ahead and copy it, and then in the Google Doc, we'll paste it. And when we paste it in, it's going to be rather large, so we'll select the graph, and then we'll resize it by grabbing that bottom right handle and dragging it inward. Good, it's looking great. We'll switch back to SPSS. We'll get our histogram for units this semester. So again, we're going to copy it, then we'll paste it, and then we'll highlight it and resize it. And you can see, by the way, both these graphs have that superimposed normal distribution to allow us to make a comparison between what the data is and an ideal normal distribution curve. All right, so we'll continue. So now we're going to evaluate for normality. Take a look at this histogram shown here. It looks kind of like a mess. It certainly doesn't look like a nice, beautiful bell-shaped curve. And whether it's going to be close enough to normal or not is important, because if it's fairly normally distributed, we will communicate, we'll summarize the results using the mean and standard deviation. If, on the other hand, we think that the mean would be unduly influenced by the distribution being heavily skewed or there being an outlier, then the mean isn't an option for us. And then instead, for a skewed or a distribution with an outlier, we would report the median and the IQR. So to be clear, the preference is the mean and standard deviation, unless there's a good reason not to. So for the sample data here, we would say good enough, and we would go with the mean and standard deviation. So how do we actually make that decision? There's three different characteristics you can consider, three tests we can look at. One is the mean approximately equal to the median? In a fairly normal distribution, they should be close. If there's heavy skew or an outlier, the mean's going to be dragged away. So that difference between the mean and median would increase if it's skewed or outlier. We'll take a look at the skewness statistic and compare this to its standard error. And I'll go into a little bit more detail about that. But basically, this is another way to assess, is the distribution fairly normal, or is it skewed? Is it tilted more to the left or to the right? And finally, we'll look at the histogram, and we'll make that judgment call. And again, unless you look at the histogram and it just shouts at you that it's heavily skewed, we'll go with fairly normal. All right, so those are three tests. And we can consider it fairly normal as long as it passes two of those tests. So if it doesn't pass all three, if it just passes two, that's good enough to consider it fairly normal and report the results using the mean and standard deviation. So let's look at examples of that. So for units this semester, our mean was 11.678, median was 12.000. The values are ranging somewhere between like 3 and 20 plus. So that's a good amount. So there's a little bit of difference. Subjective call here, not too big. So it would pass, if you will, test one at being fairly normal. Okay, then continuing to look at the units this semester, we have this measure of skewness. So it's negative, so that's implying that there could be some negative skew here, negative 0.267. But is that really significant? And by significant, I don't mean that it's big, like we use significant out there in the real world. When I say it's significant, I'm saying, can we be really certain that there is skew there? So for us to be certain that there's skew there, not guaranteed, but fairly confident that there's skew there, we compare the skewness, the absolute value, so we drop the negative, we compare the absolute value of skewness, and we evaluate whether it's twice as big as the standard error. If it's twice as big as its standard error, then we're like, yeah, that would be indicating skewness. If it's not twice as big, and that's the case here, it's not twice as big, then we're like still fairly normal. So it's passed the second of these three tests. And finally, the third is you look at the picture. You look at the histogram and you think, is this screaming at me that it is highly skewed? If it just looks like a mess, that's okay. Mean and standard deviation will work just fine with it. But only if it's like always screaming at you that it's heavily skewed, or there's just this outlier way out there by itself, would we then go like, oh, it doesn't pass the test. So for here, it's good enough. It's not shouting at us it's highly skewed. There's no like big giant outlier one way or the other. So it passes this third test. Fairly normal without an outlier. So here then are our three tests. We looked at the statistics table, compare the mean and the median. Again, look at the statistics table. We compare the skewness to twice the standard error, treating them both as positive numbers. And finally, we look at the histogram. We're like, yeah, this is fairly normal. We'll use the mean standard deviation. Okay, what about enjoyment of art? Right. So again, we're going to compare the mean and the median. And look, the mean is 5.0455 and the median is 5.0000. They're pretty close, so it would pass this. Okay, what about the skewness? You'll notice that the skewness is a negative 0.620, so that implies a negative skew, right? But is it significant? Again, when I say significant, I mean like unlikely to be due to chance, and we'll jump into that more later in this semester. Is it significant? So to make that decision, I compare the skewness to twice the standard error. You could use a calculator if you need to, but I'm looking at that 0.620, because the absolute value of it. I'm comparing it with twice 2.57, and here it's shown to equal 0.514. So 0.620 is bigger than 0.514. So yeah, this is consistent with it being skewed. So our enjoyment of art passed the first test, mean and median pretty close, but it's not passing the second test. So if it doesn't pass the third test, it's kind of like, in this case, 2 strikes and you're out. All right, so let's go. And here's the histogram, and this isn't, this is looking like it is skewed, right? So remember, we're not asking ourselves, does it look normal? Wrong question. You're looking at this and saying, is it looking really heavily like it's strongly skewed? And then if it is, then we'll say, okay, it's not normal. And yeah, clearly a skew look here. So we would say, nope, didn't pass this third test either. So here are our 3 tests. We looked at the mean and the median. It passed that swimmingly, wonderfully. We then compared the skewness, the absolute value of it, to 2 times the standard error, and no, the skewness exceeded 2 times the standard error, so it didn't pass that. And then we looked at the histogram, and it didn't pass that. So it didn't pass 2 of the 3, so we're going to treat it as skewed, which means that when we write this up, we're going to use the median and the IQR. All right, now the third step is we write it up, right? So we're either going to consider it somewhat normal distribution without an outlier and go with the mean and standard deviation, or we're going to consider it highly skewed and or the distribution includes an outlier, in which case we would report the median and the IQR. So here's our APA style write-up. We have the 90 behavioral statistics students surveyed in fall 2012, took close to 12 units, and then in parentheses we have the italicized uppercase M is equal to 11.68, comma, and then an italicized uppercase S is equal to 3.94, close parentheses. And we're using the uppercase letters here to say, like, this is describing the entire set of scores. And we're not trying to apply this to some like bigger population out there. So we're just describing our data. It's just descriptive statistics. So we're using the uppercase M and uppercase here, uppercase S. So that's it. It's short and sweet. Just 2 numbers. The M, the mean, tells us, hey, what's the center of this distribution? And the S tells us how wide is the distribution. And that's all you need to be able to draw that curve and get a sense of what does it look like. These 2 numbers, mean and standard deviation, are not going to capture this perfectly, right? You can see it's not perfect, but it gives you an idea. to work with. Okay, here's where the center is, and here's how much variability. Okay, looking at the enjoyment of art, we have the 90 behavioral statistics students surveyed in fall of 2012 generally reported enjoying art. I say generally because, there's some variability. Some enjoyed it more, some enjoyed it less. Our median is a 5. So this is on a scale from 1 to 7. So if you were to rank up all the responses, 5 would be the response right there in the middle. So that's kind of giving you an idea of what's typical. And then the interquartile range, in that case, we're taking a look at our data, and it's like you lop off, if it's sorted from low to high, you lop off the bottom 25%, you lop off the top 25%, now you're left with just the middle 50%. You say, what's the range of that middle 50%? Which we call, so that'd be like 75th percentile, that's the upper level, minus 25th percentile, that's the lower boundary. And by subtracting the 25th percentile from the 75th percentile, you get the range there. So again, the range for just the middle 50%, and that's a 3. So median, that's kind of like where should the center be. Interquartile range, that's how much variability. And then we're also sharing the skewness, like, hey, there's a negative skew here. And so those 3 pieces of information help someone to better visualize what's going on. And of course, it always helps to include a histogram, right? And it's shared that this was a scale of 1 to 7 to kind of give us some context for what is a 5 mean. So here again, we see the 2 write-ups, and that's it. That's what we're doing here. So we used SPSS to do the analysis. We got our statistics. The statistics helped us to determine whether the distribution was fairly normal or skewed, with or without an outlier. Then we wrote up, then we evaluated the normality, and then we wrote it up. So let's go into game mode now. So we only have 3 hints here. Okay, so we got to get our information. So analyze, descriptive statistics, frequencies, enjoyment of art, move it over, scroll down, units of semester, move it over, and get our statistics. We're going to go with the mean and median. One of those we'll use for what's typical, and the standard deviation and quartiles, we'll use one of those to convey the amount of variability, and we'll get that skewness statistic. We're good to go. We click continue. We go to charts. We'll choose histogram, and we'll overlay it with a normal curve. Awesome. We'll also remove the display frequency tables. That's your call. You decide. I tend to remove it, and then click OK. Then we'll copy the table, the statistics table from SPSS, and put it into our Word document, just for a handy reference. We might write up everything and then later go back and delete that statistics table, but at least we have it in the document while we're writing up our results. We go back to SPSS. We grab our 2 histograms. They're nice to include, right? We grab it, we paste it in. We're going to click on it to highlight it and then resize it. Now it's looking nice. We go back to SPSS. We get our other histogram. So we copy it, we paste it into our document, we select it, we resize it. Now it's looking good. We're ready for that write-up. And of course, then we're like, okay, am I going to share the mean and standard deviation, or am I going to share the median and the interquartile range? So we'll go through these 3 quick assessments to decide which way to go. And remember, for the sample data, this is normal enough to report the mean and standard deviation, right? And it looks like a mess. Okay, so click continue. Comparing the mean and median, we already did this. So again, we saw a small difference there for units of semester. We compared these absolute value of the skewness with 2 times the standard error of it. So we looked at 0.267, we ignored the sign, and we compared it to double, 2.54. So that's comparing 0.267 to 0.508. Skewness was smaller. It passes the test. We continue. And now we look at the histogram. We're like, yeah, it's a little sloppy, a little messy, but it's fairly normal. It's not shouting at us that it's heavily skewed. There's not like this big outlier out there. So we are good to go with reporting the mean and standard deviation. So here's our 3 tests, and it passed them just fine. So units this semester, mean and standard deviation. Looking at enjoyment of art, comparing the means and the median, and it was amazing how close they were, especially because we know, having gone through this before, that it's a skewed distribution, but mean, median, very similar. Then we looked at the skewness and we compared that. We compared the absolute value of it to to twice the standard error of it. So we looked at that 0.620, and we saw that, yeah, that's bigger than 2 times the standard error of 0.514. So we're like, doesn't pass this test. And then we looked at the histogram, and we're like, yeah, this is definitely looking heavily skewed to us. So it didn't pass that third test either. So it failed 2 of the 3, which means we're going to treat it as either skewed or with the outlier there. And so big picture, again, here are those 3 tests. Passed 1 of them, but not the other 2 tests. So we go with the skew. That means we're going to report that the median and the interquartile range. And of course, always check with your instructor how to handle outliers, because here I'm saying let's go with the median, the IQR. I do know that there's different ways to look at things, right? So always check with your instructor, your employer. Like, I'm kind of giving you the general view, but it's always good to zero in on, hey, the person you're creating this for, what are they looking for, right? Okay, so continue. And now in terms of writing up the report, this one was considered fairly normal. So we're going with the mean standard deviation. And look how tight this sentence is, right? We're conveying a lot of information in a very short, tight sentence. And we have within the parentheses our measure of what's typical. That's the mean, uppercase italicized m equals 11.68. And we also have a measure of the variability, and that's this uppercase italicized s, standing for the standard deviation, equal to 3.94. So those are our stats. Bigger picture. When you write up your results, you want to know, like, well, who are we talking about? Right? So these are behavioral statistics students. How many of them were there? There are 90 of them. And when did this take place? Fall 2012. Because in the behavioral sciences, things change over time. And so we always want to know what's the currency is. Sometimes it's interesting to know, like, what was it like in 2012, right? But we also want to know it's 2012 and not the current date, because time elapses and things change. Okay, and then notice how the write-up was the 90 behavioral statistics students surveyed in fall 2012, and we say it took close to 12 units, right? So that kind of conveys the general picture, and then now we have the more fine detail. Actually, the mean was 11.68, and we convey the amount of variability. Standard deviation was 3.94. The period goes at the very end. Looking up how we write the results for enjoyment of art, where it's skewed, or we could do this if there was an outlier. We would say the 90 behavioral statistics students surveyed in fall 2012 generally reported enjoying art. The median was a 5, the interquartile range was a 3, our skewness was a negative 0.620, and it was on a scale of 1 to 7, right? So who was it? Behavioral statistics students. How many? 90. When did this take place? Fall 2012. What was the general result? It was that they liked art. Give me the specifics, and here it is. And again, we want to keep it short and succinct and clear. All right. So click continue, and hey, it's done. So this is what it looked like. You could include a histogram, your AP style write-up for both of these, and generally that table at this point would then be deleted because it's not really conveying anything that's not already there in the report with histograms and the write-up. It was there kind of like a scaffolding. You used it while you wrote the report, and then you removed it. But again, always check with your instructor, whoever you're creating this report for, to see, what are they looking for. All right, so with it done, click next. And then if you're doing this for a course that has this embedded in the Canvas quiz, you'll have a 4-digit passcode. So in this case, let's say it was 3478. You would type that in, the quiz will give it to you, you click OK, and our completion code is 441. You would enter that in as your answer to the quiz question, and in that way you get the answer right. Okay, thanks so much for journeying with me as we talked about scale variables and how to evaluate them, analyze them, and write them up APA style.